Today we're testing two proportions. Great news, 3 of these videos left, just 3. And then you are gonna be completely working on your project. Yay! So get excited, this is your last week of all information. Hopefully you've been emailing me your questions that you may have for the project, making sure you picked a really good question because you are gonna need to collect your data. First things first, we're just gonna, hopefully you have actually, downloaded this sheet right here, testing the difference between two proportions. I actually pre-wrote this out, formula and assumptions, and then I'll write what the TI calculator is, but I put it on this sheet already because I forgot I actually had written it on that sheet. But I did want to show you the formula for the test statistic for testing two proportions. Looks so complicated and crazy, doesn't it? Now, I still would like you to write this down. I kind of would like you to explain this to you. We don't use the test statistic. And when we did last chapter in 8, we looked at the test statistic to see where that critical value was. But we use the P method, okay, the p-value method. But I still think that this is quite interesting. I mean, look how complicated it looks, but really, what is it saying, okay? Your test statistic, Z, for testing two proportions would be P1 hat. So again, you have two different percentages here, percent of boys to girls, whatever. And this would be from your sample, X1 over N1. Your first sample, let's say boys. This would be from your second sample, X2 over N2. This would be the populations that you already know from a previous study, the populations, okay? Then we got our P hat, Q hat, which we know that and we love that. P hat, Q hat times 1 over N1 plus 1 over N2. And then you take the square root of that and that'll give you your Z test statistic. Now, of course, the calculator is going to figure it out for us, but very interesting. And if you take a statistics course, you might have a professor that wants to see all that work, but you can do it. You can handle it. But we're not going to even really worry about this. I still think it's pretty cool. Write it down. Something to know. There are 3 assumptions. Sorry about this wet spot here. I think it's from my water bottle. It's a water bottle, I promise. Assumption number 1, samples are random, okay? Obviously, even in your project, I want you to do something random, okay? I know you're probably going to do your polls on Instagram or, ask people around you, but try to be random about it. Oh, I collected every 5th person. Something random, please. Samples are independent from each other. Again, we don't want to test males and females where one of the females says she's a male. We want them to be independent from each other. And in your samples, your N times P has to be greater than 5, and your N times Q has to be greater than or equal to 5. All right. So write all that down. Now, let me tell you what it is in the TI calculator, okay? You're going to go to Stat. You're going to go to Tests. And you're going to go to two proportions, Z test. Okay, please be very careful. Look here at the calculator. Stat, tests. There's 2 sample Z test. No, we're doing proportions. 2 sample T test, 1 proportion Z test. No, now we're doing 2 proportion Z test. Okay, 1 proportions was from the last chapter. So that's number 6, 2 proportion Z test. Let's just look at number 6. Look at the things you're going to need. You're going to have an X1 and an N1. So you're going to have the sample of, let's say, 50 boys. That would be your N. And how many of those boys, like the movie Frozen 2? And then you're going to have a sample of girls, 50 girls. And how many of those girls like Frozen 2? That would be X2. And then you put your P, you're comparing your proportion of one to the proportion of the other, and then we calculate. All right, so now that we've seen that on the calculator, let's kind of look through this example right here and decide what is our X1, what is our N1, what is our X2, what is our N2. And that's really all we need from the calculator's perspective. If we were doing the formula method and calculating the test statistic, we'd have to do a few more things, but it's all good. A study found that in a random sample of 50 burglaries, 16% of the criminals were arrested. In a random sample of 50 car thefts, 12% of the criminals were arrested. At the 10% significance, can it be concluded that the percentages of people who committed burglaries and were arrested was greater than the percentages of people who committed car thefts? Okay, so let's talk about what these numbers mean. 50 burglaries, what is that? Yeah, that's our N1. How many things? 50, okay? So we'll call that our N1, which means the 50 car thefts would be our N2. 50-50. All right, now, from those 50 burglaries, 16% of those criminals were arrested. You don't want to put 16%. Remember, that's a P. That's like your P1, your P1 hat. We need in the calculator the X. So how do we figure out the X? If what out of 50 would be 16%? Well, a way to do that is, you can write this down, X1 would be 16% of 50. 16% of 50, which is 8. Because 8 out of 50, that makes 16%. Okay? So in your calculator, you're not going to put the percent. There's nowhere for percent. Look, there's nowhere here. Actually, there's a glare there. Here we go. There's nowhere. You need to put an X and an N. Don't put 0.16. Be careful. All right, so in the random sample of 50 car thefts, 12% of the criminals were arrested. So what do I do there? Well, same thing. X2 would be 12% of 50, which is 6. All right. And that would make 12%. All right, so we're looking to see if the people who committed burglaries, which is our ones, is greater than the percentages of people who committed car thefts. Okay, so let's go through our steps here. Number 1, HO would be that the percentages are equal. The population percentages are equal. My alternative, though, my claim is that no, the burglaries is greater than car thefts, P2. Okay. Step 2, what's our significance level? Alpha 0.10. Step 3, we are going to use the calculator we're going to do our p-value method. Okay. So let's use our calculator. Stat tests 2 prop z. Move this over. Our X1 is 8 and 1 is 50. X2 is 6 and 2 is 50. Now, we don't want that the proportions are not equal. We want that the proportion 1 is greater than proportion 2 for our hypothesis testing. We're going to calculate. Okay, now look at all these things that they've given to us. This is the Z that you would have gotten had you done this formula. The calculator gave to you. So I don't know why professors make you do it, but they do. Okay, this P that's underneath the Z, that is your p-value. This is p hat 1, which is 16%, which is true. This is p hat 2, this is 12. So I did it right because I got a 0.16 and a 0.12 here. Our proportion for the population is 0.14. And then it has our n's. But this second p right here underneath the Z is what we're looking at. So p, our p-value is 0.28. 0.28. Which is greater than 0.10. So do we reject or not reject? Do not reject the HO. And now you've got to use words because we need to know what the P1 was that you used and what the P2 was that you used. So here's what we just found out, was that there is not enough information. There is not enough info. I should say evidence. There is not enough evidence to support the claim that people who committed burglaries is greater percentage than car thefts. Whoops, not care, car. Okay. So simple, simple, simple. Same things that you've been doing. All right, you're going to try these 3 problems right here, page 525, 11, 12, and 14. Take a picture, send it to me. All right, only 2 more videos to go. Bye, guys.